All right, so we're going to start looking at logarithms in this next lesson. So really what a logarithm does is it helps us find an exponent. So if you had something like an equation like this, you would be able to solve for x probably by guessing and checking. You would realize that x is 2. But what about if you had an equation like this? Then you wouldn't really be able to figure out the exact value of x. So you'd actually have to use a logarithm. So logarithms are used to help us find exponents. So it helps us solve for an exponent. So first of all, we are going to convert each of the following from logarithmic form to exponential form. So you can go back and forth between logarithm and exponential. So I like to always start with the base. So I have 7. The logarithm, remember the purpose of a logarithm is to find an exponent. So whatever the logarithm equals, that's your exponent. So I'd have 7 to the exponent of 4, and it equals my argument. We call this other number on the right-hand side an argument. All right, so I want you to press pause and see if you can figure out the rest of the questions. So the next one, my base is 5 to the exponent of y equals my argument, which is 15. The next one, when you convert logarithms, you actually want to isolate the logarithm to start with. So I'm actually going to divide this 5 over. So I end up with 1 equals log b 6. So my base is b, my exponent is 1, and it equals my argument, which is 6. All right, this one, the logarithm is already isolated, so I can go straight to converting to exponential form. So my base is 5, my exponent is x, and it all equals my argument, which is 7y. All right, now we're going to do the opposite. So we're going to go from exponential form to logarithmic form. So I'm going to write log. My base of my exponent is the base of my logarithm. Okay, whatever my exponent equals, that's the argument. And remember, logarithms always equal the exponent, which in this case is 3. Now press pause on the video and see if you can figure out the rest. So the next one, log, my base is 2, my argument is 1 over 8, and it all equals my exponent, which is negative 3. And then my next one, log, my base this time is a. Apparently I can't write log. Let me try that again. So I have log, my base is a, my argument would actually be 2x plus 4, so I'm going to use brackets just to show that that whole expression is part of the argument of the logarithm, and it equals my exponent, which is 5. Okay, so just like logarithms, remember how we had to isolate the log before we can convert to exponential? The same holds true for exponential equations. We have to isolate the exponential function before we can convert to a logarithm. So in order to do that in this question, we're going to have to divide that 2 over. So now I have log, my base is 3, my argument is y over 2, and it all equals my exponent, which is x. There we go, just like that. Okay, so now we're going to evaluate. So when we evaluate, you guys will have different calculators. So I'm going to show you a few different ways. So let's take our graphing calculator out. Okay, so when we type this in our calculator, what I want you to do first is go to math, and then you're going to scroll down and see if you have this log base question button. So it looks like I do on this one. Crazy. Okay, and then you're going to press enter. Okay, so then our base, if you go back to that PowerPoint, the base was 4 and the argument was 16. So you're just going to go ahead and type that in your calculator, and your answer is 2. Now if you don't have that log base button, what you're going to do is you're going to take the log of the argument and divide it by the log of the base. And you should still get 2. So if you have the special button, use it. If you don't, a lot of older models of the TI-83 don't have that, then you just take the log of the argument divided by the log of the base. Okay, so what I want you to do is I want you to try typing these other ones in. So here we should get 2 Here, if you type this in your calculator, something else I'm going to point out, what we're dealing with here, these are common logarithms. So common logarithms always have a base of 10 unless stated otherwise. So that means this is the same as this. So whenever the base isn't there, assume it's a 10. So when you're typing it in your calculator, you can actually just type log 100,000 and your calculator will automatically assume it's a base of 10. So go ahead, try typing that in. You should end up getting 5. All right, so here's the same thing. You're going to type log 8, 512. You should be getting 3. 2 times 3 is 6. In this case, even though that's an exponent, you do the exact same thing. So start by typing that logarithm in your calculator. Log 525 is equal to 2, and 5 squared equals 25. So our answer is 25. Now for this next question, you're going to see examples like this throughout the unit. Whenever they use a variable, if you get stuck, you can always substitute a value in, just like we've done previously. So you could try typing, like, make B5. Generally speaking, whenever you have an argument and a base that's the same, it's going to always give you 1. The reason being is because if we used 5, for example, 5 to the exponent of 1 gives us 5, right? So whenever we raise something to an exponent of 1, it always gives us an answer that's equivalent to the base of the exponent. Okay, and same here with the second one. You could just use a number and try typing that in your calculator. However, no matter what number you end up using, you'll end up with 0. The reason being is 5 to the power of 0 equals 1. So whenever you raise something to the power of 0, you end up with 1 as your answer. Okay, so now we're going to go ahead and solve these and figure out x. So in this first question, I'm actually going to convert this to exponential form to solve for x. So my base is 5, my exponent is -3, and it all equals my argument, which is x. Now I'm going to go ahead and type that in my calculator, and I end up with 1 over 125. The next one, my argument is x, my base is 64, and my exponent is 2 over 3. If I type that in my calculator, I'd end up with 16. Okay, so in Math 30-1, we only deal with common logarithms, which we already talked about. Natural logarithms, if you ever see something with ln x, that's actually not in this curriculum. What a natural logarithm is, though, is it has a base which is an irrational number, similar to pi, e value, which is on your calculator. But once again, we don't actually have to worry about that for 30-1. Okay, we've already talked about this as well. So this is kind of the change of base identity. Pretty much how we use that in this course is if you end up with a graphing calculator that you don't have that special button, and I told you, so for example, I told you to type it in your calculator as log the argument divided by log the base. So the reason that works is because of the change of base identity. So in this case, this is equivalent to this expression because they both have a common base of 10 in this case, but really it would be true for any common base. That doesn't come up too much in the course, more so just a strategy when you're using the graphing calculator. Here's some questions to try. You really need to make sure you understand how to convert back and forth between exponential and logarithm form. So please do these questions as soon as possible because we will continue to build on these concepts.